All right, so here we've got an integration application. It says a car braked with a constant deceleration of 16 feet per second squared, producing skid marks measuring 200 feet before coming to a stop. How fast was the car traveling when the brakes were first applied? All right, so let's set up what we know. We're going to have to get to a position function. So we know that the acceleration, a of t, is negative 16 feet per second squared. They give us that right there. All right. And if we have this right here, well, my velocity is the integral of the acceleration function. So my velocity is negative 16t plus a constant. Now, let's go ahead and think about this. Let's make our constant v0. Okay, I could have made the constant anything. I could have called it c, d, whatever. Okay, I just chose to call it v0. Now, what is v0? Well, v0 is, and let me use a different color you can see a little better. So v0 is car's speed when brakes were applied. Okay, so that's v0. Now, what else do we know? Well, we know that it produces skid marks measuring 200 feet before coming to a stop. So when it comes to a stop, the skid marks were 200 feet. Okay. So we also know that the car stops when the velocity is 0. Okay. So what I need to do is I need to figure out the position function, and then I can plug in the time that the car stopped, at what time the car stopped when the velocity was 0, and then I can solve for this v0. So let's look at that. Let's write it down. It'll probably make more sense. All right. So if I do v of t equal to 0, that's negative 16t plus v0 equals 0. So that tells me t is v0 over 16. All right. So at that time, the car has come to a stop. And also at that time, the length of the skid marks was 200 feet. So let's come up with the position function. So s of t, I'm going to write that down here. So s of t is equal to the integral of negative 16t plus v0 dt. So s of t is equal to negative 8t squared plus v0 times t plus some constant, we'll just call it s0. All right. Well, in this case, I know that s0 is 0 because S of 0 is equal to 0, because at time t equals 0, remember at time t equals 0, that's when the brakes were first applied. So right when the brakes were applied, the length of the skid marks was 200 feet. So you can see if I do S of 0 is equal to negative 8 times 0 squared plus V naught times 0 plus S naught equals 0. Well, this tells me that S naught is equal to 0. So S of t is equal to negative 8t squared plus V naught times t. Okay. All right. So, because see, all I did is I plugged the 0 in for S naught. All right. So what am I looking to do? What is it asking me? How fast was the car traveling when the brakes were first applied? Okay. Well, let's see what I know. Well, I got to find V naught, because V naught is the car's speed when the brakes were applied. Well, what I do know is I know that S of V naught over 16, which is negative 8 times V naught over 16 squared plus V naught times V naught over 16, I know that is equal to what? 200. All right, because remember, this right here is the time when the car came to a stop. And when the car came to a stop at this time that I plugged into here for t, the length of the skid marks was 200 feet. All right. So that's going to give me, if I square this, I get V naught squared over 256. Okay. And negative 8 over 256, that is negative 1 over 32 V naught squared plus 1/16 V naught squared equals 200. Combine like terms here, I get 1 over 32 V naught squared equals 200. So V naught squared is equal to 6,400. So I get V naught is equal to 80 feet per second. And there's my answer. And yes, this is plus or minus, but we don't use the minus because we're not going to have minus feet per second. So this is 80 feet per second is the velocity of the car when it first applied its brakes. All right, so I hope this video helped. Check out my other videos. Give me a like, share, and subscribe, and thanks for watching.